2022, researchers at a remote field station in Sumatra filmed a wild orangutan doing something no one had ever documented an animal do to itself before. His name was Rakus. He had a fresh, open wound on his face, almost certainly from a fight with a rival male. Over several days, researchers watched him chew the leaves and stem of a specific vine, Fibraria tinctoria, a plant known locally for its pain-relieving and antimicrobial properties, and repeatedly apply the chewed plant paste directly onto the wound with his fingers not eating it, applying it precisely onto the injury, and nowhere else on his body. Within days, the wound showed no signs of infection. Within a month, it had closed almost completely, with minimal scarring. This wasn't the first time scientists had suspected animals of medicating themselves. It was the first time anyone had filmed one doing it to an open wound, using a plant with pharmacologically active compounds, applied with what looked unmistakably like intention. The field this behavior belongs to has a name most people have never heard: zoopharmacognosy, the study of animals self-medicating using natural substances. It sounds like a fringe idea until you look at how much documented evidence has accumulated behind it. Chimpanzees offer the clearest long-term case. Primatologist Michael Huffman spent decades studying chimpanzees in Tanzania who, when suffering from intestinal parasites, sought out a specific plant, Vernonia amygdalina, known locally by the Swahili word for bitter leaf. Chimps normally avoid this plant entirely. It's intensely bitter, and healthy chimps show no interest in it. But sick chimps, showing clear symptoms of parasitic infection, would travel out of their way to find it, strip the bark, and chew the exposed pith, swallowing the bitter juice while spitting out the fiber. Laboratory analysis found the plant contains compounds with measurable antiparasitic and antimicrobial activity. Huffman documented chimps recovering from diarrhea and parasite loads within 24 hours of self-dosing, a recovery timeline consistent with the plant's known pharmacological effects rather than coincidence. Chimpanzees do something even stranger with a second plant, one that has nothing to do with chemistry at all. In several populations, sick chimps have been observed selecting specific rough-leaved plants, folding the leaves without chewing them, and swallowing them whole. Researchers who examined chimp feces afterward found the leaves pass through completely undigested, their rough surface texture physically scraping intestinal parasites off the gut wall on the way through a mechanical deworming method, not a chemical one, using a plant selected specifically because chewing it would defeat the purpose. This means chimpanzees are choosing between two entirely different medicinal strategies, chemical or mechanical, depending on the plant and, apparently, depending on what's needed. Elephants complicate the picture by extending self-medication into reproduction. Researcher Holly Dublin, studying elephants in Kenya in the 1980s, documented a pregnant elephant traveling a significant distance out of her normal range to specifically seek out and eat the leaves of a particular tree in the Boraginaceae family, a plant local Samburu and Kikuyu women had used for generations as a traditional labor-inducing remedy during childbirth. The elephant ate nothing else from that excursion. She gave birth days later. Dublin was careful about the limits of a single observation, but the overlap between traditional human medicinal knowledge in the same region and the elephant's specific, targeted foraging trip was difficult to write off as coincidence. Birds handle self-medication at the level of architecture rather than digestion. Researcher Larry Clark found that European starlings deliberately select specific aromatic herbs, including wild carrot and yarrow, to line their nests plants they otherwise never eat and rarely interact with. Laboratory testing found these herbs release volatile compounds that suppress the hatching of parasitic mites and reduce bacterial loads in the nest environment. Starling chicks raised in nests lined with these herbs showed measurably better immune markers and higher fledgling weight than chicks in nests without them. The starlings aren't treating themselves. They're pharmaceutically treating the environment their offspring will grow up in, selecting specific plants for a chemical effect the birds themselves never directly experience. Insects push self-medication somewhere researchers didn't expect to find it at all. Woolly bear caterpillars infected with parasitoid fly larvae, which slowly consume the caterpillar from the inside, will deliberately shift their diet toward plants containing toxic alkaloids that the caterpillar would normally avoid or eat in only small quantities. Researcher Michael Singer found that infected caterpillars eating these toxic plants had significantly higher survival rates than infected caterpillars kept on their normal, non-toxic diet, because the toxin was more harmful to the parasitic larvae than to the caterpillar itself. Healthy, uninfected caterpillars showed no craving for the toxic plants at all. The shift in appetite appeared to switch on specifically in response to the internal infection in an animal with a brain smaller than a grain of rice and no capacity for anything resembling the reasoning involved in Rakus treating his facial wound. What connects Rakus with a chewed leaf poultice, a chimpanzee stripping bitter bark, an elephant crossing her range for a labor-inducing leaf, a starling lining its nest with mite-repelling herbs, and a caterpillar switching to a toxic diet under parasitic attack is not a shared understanding of medicine in any sense a human would recognize. Researchers are explicit that these behaviors likely sit on a wide spectrum, from something close to instinct, hardwired by evolution over millions of generations, all the way up to something that, in Rakus's case, looks disturbingly close to reasoning, recognizing an injury, recalling a specific plant's effects, and applying it precisely where needed, then continuing to reapply it over multiple days as the wound healed. Nobody taught Rakus to do this. No other orangutan at that field site had ever been observed doing it before or since. Which leaves the harder question sitting underneath all of it, one researchers studying self-medication return to again and again. If a caterpillar with almost no brain to speak of can somehow select the exact toxic plant that kills its parasite without killing itself, and an orangutan can independently arrive at treating an open wound with a plant humans use in their own traditional medicine for the exact same compounds, how much of what looks like human medical knowledge was never actually invented by us at all, just noticed a little later than everyone else already knew?